friends, I am Faria Amina. Today we are going to learn about real numbers, first chapter of 10th class mathematics. To understand real numbers, we have to understand what is a number line first. That is, a number line is a line on which we put the numbers. 0 is here on the number line, then positive numbers to the right of 0, that is here 1, 2, 3 and so on. Similarly, negative numbers to the left of 0, -1, -2, -3 and so on. So these numbers are there on the number line. Similarly, we have unlimited numbers on the number line. So let us see some examples. That is, suppose -2. This -2, it is plotted on the number line. What about 3? 3 is also plotted on the number line. What about 7? 7 is somewhere here to the right side. It is also plotted on the number line. What about the 2.5? 2.5. 2.5 lies between 2 and 3. It lies somewhere between 2 and 3. So all these numbers, even decimal numbers, all these numbers, the numbers which are plotted on the number line are called the real numbers. So that is the main definition of the real numbers. Simple definition. The numbers which are plotted on the number line are called real numbers. Now along with that we have some different types of numbers. That is, first we will see natural numbers. As we all know about the natural numbers. Natural numbers starts from the 1, 1, 2 and so on. So this is a set of natural numbers. Then we have a whole numbers. Set of whole numbers. It starts from 0. 0, 1, 2, 3 and so on. So this is a set of whole numbers. Along with that we have an integer. We have seen this number line. So this is a number line of integer. Integer we can use the symbol Z or I. So 0 here, 1, 2 positive numbers here, negative numbers here. So this is a set of integers. So these are the different types of numbers. Now let us know about the rational numbers. Rational numbers. What are rational numbers? Rational numbers means the numbers which can be written in the P by Q form. The numbers which can be written in the P by Q form and Q is not equal to 0. So this kind of numbers are called rational numbers. In rational numbers we have two types, that is terminating decimal and non-terminating recurring. Terminating decimals, terminating decimal, and we have non-terminating recurring. Terminating decimal means 2.567. It ends at 7. 2.567. It ends at 7. So that means it terminates. So that's why these kind of numbers are called terminating decimal. Non-terminating recurring means, example, 0.66 and so on. This we can write as 0.6 bar. Here the numbers are non-terminating. That means they will not stop and they will recur. That means same number is again and again coming. So we can write this as 0.6 bar. Again and again we are getting 6, 6, 6, 6, 6. Such kind of numbers are called non-terminating recurring decimal. So this comes under rational. Then we have irrational. Irrational numbers we have. Irrational numbers means it is opposite to rational. That means the numbers which we can't write in the form of P by Q. Can't write in P by Q form. The numbers which we can't write in the P by Q form are called irrational numbers. In this we have one type, that is non-terminating and non-recurring. Recurring. That means we can take examples of 3.146 and so on. See, look at here, 3.146. After 6 also I am writing dots. That means after that also we are having unlimited numbers, non-recurring numbers. So the numbers which you don't stop. That means 3.146. This is an example of non-terminating, non-recurring. It comes under irrational numbers. So rational and irrational together are there. So that means why I am teaching about rational and irrational, because rational and irrational together is also called a real number. Rational and irrational together is called a real number. We have one more definition of real number. First definition, we have the numbers. Any number that can be written on the number line is called a real number. One more definition we have, rational and irrational together is also called a real number. Let us know about the rational and irrational, that is Venn diagram of real numbers. First, this is a set of natural number 1, 2, 3 positive numbers. In that we can include one more set, that is including 0, 0, 1, 2, 3. So it is a whole numbers, natural numbers, whole numbers. Inside that we can use integers. We can see here natural numbers, whole numbers is including 0, 0, 1, 2, 3, all these are whole numbers. 0, 1, 2, 3 positive numbers and negative numbers are called integers. -1. So this is an integer. Natural numbers, whole numbers, integers together we will get a rational number. Together we will get a rational number. So all natural numbers, whole numbers, integers comes under rational numbers. We can take this 2 by 3, some more examples. Now one more set we can draw, irrational numbers. Pi, √2, √3. This kind of numbers comes under irrational. So rational and irrational together we are getting a real number. So this we can say this is a Venn diagram. So this is a Venn diagram of real numbers. Hope you have understand. There are two definitions of real numbers. First is any number that is plotted on the number line is called a real number, and one more is rational and irrational together is called a real number. Let us do some division problems. Find Q and R for the following positive integers A and B satisfying A is equals to BQ plus R. Here we have first problem. Take A equals to 13 and B equals to 3. So here we will take A as a dividend and B as a divisor. So let us divide. 3 4s are 12, 3 minus 2 is 1, remainder is 1. Here Q is quotient, we have to find Q and R. So Q is 4 and R is 1. So we can write Q is equal to, quotient is 4 and remainder is 1. This problem we have to satisfy for the given equation, that is A equals to BQ plus R. Already we have A equals to 13. So put A is 13 equals B is nothing but 3, B into Q. So 3 into Q, quotient we got 4 plus remainder 1. 3 4s are 12, 12 plus 1, 13. Here we are getting same answer. That means the equation is satisfied over here. Now let's do another problem. A equals 125 and B equals 5. So 5. Again we will do the another problem. 5 to Z 10. 2 minus 0 is 2. 5 5s are 25. In this case we are getting remainder 0. Let us verify with this equation. A is equal to BQ plus R. Here we are having A. Here we got Q. This is Q quotient 25, and here we are getting remainder 0. Let us satisfy with this equation. A is 125 is equal to B. We are having 5. 5 into quotient we got 25 plus 0 is the remainder. Remainder we are getting 0 here. So 5 into 25 is 125 plus 0, 125. So same answer we are getting 125. That means it is satisfying the division method for these equations. That is this equation A is equals to BQ plus R. For same thing divisions, taking A as 132 and B as 11. Let us verify for this. 11 you have to divide by 132. 11 ones are 11. This is nothing but just simply a division. 3 minus 1 is 2. 11 twos are 22. Here so we are getting remainder 0. So we have to find Q and R. So we got Q 12 and R remainder 0. And this is the quotient. Again we have to verify for it. A is equal to, we have to satisfy for A equals to BQ plus R. We have A 132 is equal to B, we have 11 into Q we have 12 quotient plus R. R is the remainder 0 we are getting. 11 into 12 is 132. 132 plus 0 we are getting 132. That means these two equations are getting satisfied. Here we are getting same answer. Left hand side 132, right hand side also 132. So these are the problems of divisions. So why we are doing this? These are just the division, but we are using this equation. A is equal to BQ plus R. Here A is nothing but A is a dividend. A is a dividend, B is a divisor, Q is quotient, and R is a remainder. So this equation is nothing but it is satisfying for the division method. A is equal to BQ plus R. We have seen some examples which is satisfied for the above equations. So why we are using this this method? This method we are using just to apply the Euclid division's lemma. Let us learn about the Euclid's division lemma. So we have Euclid's division lemma. What that means? Euclid means, this is the name of the Greek mathematician. He is also called as father of geometry. Division means we are dealing with division problems. That means we are dealing with division of integers. Lemma is a proven statement to prove another statement. So the definition of lemma is nothing but it is already a proven statement that we are applying to prove another statement. For this we have one statement we have for this Euclid division's lemma, that is given positive integers A and B, there exist two positive integers Q and R, satisfying A is equals to BQ plus R for the condition of remainder. That means R is greater than and equal to 0 and it should be less than B. This is the condition. This is the Euclid division's lemma statement, that is given positive integers A and B, there exist two positive integers Q and R, satisfying A is equal to BQ plus R. We have to satisfy for this. For the condition, remainder should be greater than and equal to 0 and it should be less than B. Why it is less than B? Because whenever we divide, we will divide like this. Since A is a dividend, we will write here. B is a divisor, we will write here. And if we and Q is a quotient, we will write here. If you multiply this, we will get some answer here. Then after subtraction, we will get the remainder. That means always remainder should be less than divisor. That's why we are using the condition, that is radius r should be always greater than and equal to 0 and it should be less than b. For this condition you have to use Euclid division's lemma. For this we will do some problems. Same thing we can do. We will have let us take a equals to 18 and b equals to 4. Let us do for this. Then here we can 2 4 4 is 16. 18 minus 8 minus 6 we will write 2. We are getting remainder 2. A is 18, b is 4, q is r, q is 4 and remainder is 2. That means we have to check. Let's see here, remainder 2 is it is less than b. We can see that remainder less r is less than b. We are getting remainder 2 is less than 4 according to the given problem. So if we satisfy, that is a is equals to bq plus r. Let us verify. 18 is equals to b, 4 into q, we will write 4 plus remainder 2, that is 4 4 is 16 plus 2 is equals to 18. Hence it is satisfying and we can see remainder r is less than b. So remainder is 2 and it is less than b. So this is the example of Euclid's division lemma. Now we have Euclid division algorithm. Euclid division's algorithm is a technique to find the HCF, that is highest common factor. It is a technique to find HCF, that is highest common factor of any given two numbers. So let us have some, I think you all are familiar with HCF. Let us see one example, that is find HCF. Example, find HCF of 300 and 550. Let us find the HCF of these two numbers. This HCF we are going to use for Euclid division's algorithm. How to find the HCF? So this is the smaller number, we will take it as a divisor and 550 as a dividend. So now let us apply. 300 ones are 300, 300 twos are 600, which we can't apply here. So 300 ones are 300. 0 minus 0 is 0. 5 minus 0 is 5. 5 minus 3 is 2. It's 250. 250. Now here this is A, this is B. Using the method A is equal to BQ plus R. This is A, this is B, this is Q, this is R. Now to find the HCF, what we have to do, this remainder we are making as a divisor, and this divisor we are will make as a dividend. We have to solve the steps till we get the remainder 0. Now 250 ones are 250. What we have to do, we have to subtract this to get the remainder. 0 minus 0 is 0. 0 from 0 we can't subtract 5, borrow 1. So we will get 10. 10 minus 5 is 5. 50. Now again we are not getting remainder 0, we are getting it 50. Now what we will do, we will make this 50 as a divisor. Now again we will do this. This one we will take as dividend. Now 50, how many times it comes in? 250. 50 1 50, 5. 15 5 is 250. Now 55 is 250. We are getting remainder 0. Now the answer is finished here. So what is the answer? What is the HCF here? HCF is nothing but this, the last divisor is the HCF. These steps we can write in this form: A equals to BQ plus R. A equals to BQ plus R. In the first step, this is A, this is B, this is Q and this is R. 550 is equals to B. B is 300 into Q. Quotient is 1 here, plus remainder is 250. This is the first step. Okay, this is the first step. In next step we have changed this remainder, we have taken as the divisor, and this divisor we have taken as a dividend. So now the next step, in the next step we are writing 300 as A equals B. B is 250 into quotient. Quotient here is 1 plus here we are getting remainder 50. Okay. So this is our next step. A is equals to BQ plus R. This is our next step. Now what about this? We got 3 steps, 1, 2 and 3. This is the last step. As we got remainder here, we have to stop here. Now here this is the 250, 250. 250 is the dividend A. 250 equals to B is 50 into quotient is 5 plus remainder is 0. Since we are getting remainder 0, so actually what we have to do, we have to find HCF, highest common factor of 300 and 550. To find this, we have used this step. Now what will be the answer? Is it 5 or is it 50? Some students get confused about the answer. Here answer is nothing but 50 is the answer, the last divisor. Here we got the remainder 0, the last divisor 50 is the HCF of the given numbers. So HCF is, this is the answer. HCF of 300 and 550 is 50. This is the division method to find the HCF. So Euclid's division algorithm. This is an example of the Euclid division's algorithm. To do this, we can use one more example. We will do some problems to find HCF. So second example we will take HCF, find HCF of 50 and 70. We will take this example, right? So the smaller one we will take as a divisor, the bigger one we will take as a dividend. So 50 is here. So 50 1 is 50, 50 2 is 100, that we can't use. So we will take 50 1 is 50. Now after subtraction, 7 minus 5 we will get 20. Now since we are not getting remainder 0 here, for this is the first step. We will write as A is equals to BQ plus R. So what is A here? A is 70, B is 50, quotient is 1 and remainder is 20. So let us apply here. 70 equals B is 50 into Q 1 plus remainder is 20. If you want, we can prove it also. 50 1 50, 50 plus 20 is 70. So we are getting equal answer. In this way we can satisfy also. Next is, since remainder is not 0, we will take this remainder as a divisor and make this divisor as a dividend. Now let us divide this. 21 the 20, 22 the 40, 23 the 60. 60 we can't apply. So we will take 22 the 40. 0 minus 0 is 0, 5 minus 4 is 1. Look, again we are not getting remainder 0. This is the next step. We can apply here. 50, A is 50 equals, what is B? B is 20 into remainder is 2 plus Q is 2, Q is 2, remainder is 10. 22 is 40, 40 plus 10, 50. See, answers are equal here, left hand side and right hand side answers are equal here and here also. Then since we are not getting remainder 0, we will take another step. Let us take this remainder as a divisor, then 20 here, dividend, 10 1 is 10, 10 2 is 20, remainder here 0. So see, can you see remainder 0? Yes, we got the remainder 0. So answer is stopped over here. Can you tell what is the HCF here? Just looking at this division method, we can say 10 is the HCF of 50 and 70. We will write based on this method, that is 20, A is 20 equals B is 10 into here also quotient 2 plus remainder 0, 10 to the 20, 20 is equals to, here it is satisfied. That means after this division method we are getting remainder 0, we will stop answer here. The HCF is 10. HCF of 50 and 70 is 10. HCF of 50 and 70 is 10. So this is the method to find, division method to find HCF. Hope you have understand. Let us do one more problem of HCF. HCF of 96 and 72. Let us do this third one. HCF of 96 and 72. So is it easy to do? Which one we will take as A and B? This is the bigger one and this is smaller one. Bigger one we will take as A and the smaller one we will take as B. So this one we will take as A and this as B. What is A? A is nothing but a dividend. And what is B? B is nothing but a divisor. So what we will do next? We will divide this again, the same process for these two numbers. 72 we will divide by 96. Do you remember the table 72, multiplication table? No, but if you don't remember, you have to multiply and get the answers. Since the digits are 2 digits only, simply we can write 72 ones are 72 here. Because 72 2s is 2 to the 4, 2 7 are 14, 144. 144 which is bigger than 96, that we will not apply. So we will take 72 ones are 72. Now what we will do next? Subtract. 6 minus 2 is 4. 9 minus 7 is 2. Is it right? 24. Now we will use this concept A equals to B plus R, same thing. This is the first step. Here A is nothing but 96. 96 equals B is 72. 72 into Q. What is Q? Q is, we got 1 here and this is remainder R. Q is quotient 72 into 1 plus remainder is 24. We can prove it also. 72 ones are 72 plus 24, that is 96. Here we are getting equal. Actually no need to prove, but let us satisfy it. What is actually what we have to do? We have to find HCF. So till we get the remainder 0, you have to go on solving this. You have to go on take this step by steps till we get the remainder 0. Now what will be the next step? This remainder 24 will take as divisor, 72 will take as dividend. Now do you remember the multiplication table of 24? If you don't remember, what we have to do, you have to calculate it to the right rough side. We all know 24 on the 24. Let us see 24 into 2, 2 4s are 8, 2 to the 4, 48. 48 is very less than 72. So we will do 24 into 3. 24 into 3, 3 4s are 12, 3 2s are 6, 7. So exact answer we are getting 24 into 3 is 72. So 24 3s are 72. We are getting remainder 0. So this is the answer. We only in the 2 steps we got the answer. That is what will be the HCF here? 24 is the HCF. This is the next step. That is A equals to BQ plus R. A is 72. What is B? B is 24. 24 into Q. Quotient is 3 plus remainder is 0. 24 3s are 72 plus 0, that is 72. So we are getting answer 72. That means the equal answer we are getting. So actually just we are applying because it is a Euclid division lemma that we are proving it. But actually what we have to do here, we have to find the HCF, highest common factor of both these numbers. This is the division method to find it. So HCF of 96 and 72 is nothing but 24. We will write HCF of 96 and 72 is 24. So 24 is the answer. Hope you have understood, because we have done 3 examples of HCF.